See about basics of scattering parameters and the derivation of scattering matrix for 4-port network. So there are many parameters like A, B, C, D, Z, Y in microwave engineering. But why? Because we opt for the scattering parameter, that is S parameter, because for the analysis of microwave components we choose only these S parameters. The reason is because the three main reasons are that it is not possible to have open circuit and short circuit at microwave frequencies. It is the one of the reason. And other one is equipments are not allowed to measure total voltage and total current for microwave frequency. And the third reason is that active devices like tunnel diodes, impact diode, microwave transistor, etc. have a problem of stability at microwave frequencies. So because of these three reasons, we choose the scattering, that is S parameter, for the analysis of microwave components. So S scattering parameter is nothing but we use this method for the analysis of the microwave components. So how to measure this S parameters means we use the notation S to the subscript Ij. Ij is nothing but the ith port and the jth port. This ith port, it indicates the reflection at the ith port, and J indicates the incident at the J port. So for the convenience, let denote the symbol A for the incident and B for the reflection for understanding. So when the formula, basic formula is that Sij is the notation for scattering parameter, is calculated by normalized, calculated by ratio of normalized reflected wave at the ith port to the normalized incident wave at the jth port. So already I said, for the convenience, reflected is denoted by symbol B and incident is denoted by the symbol A. So at the port I means Bi by Aj is the notation. So Bi, that is reflection at the ith port, can be calculated by Bi equal to reflected voltage wave at the ith port to the square root of the Z0 I is nothing but the characteristic impedance at the ith port. So likewise, to calculate the incident wave at the jth port, the formula is ratio of incident voltage wave at the jth port to the square root of the Z0 J. That is nothing but the characteristic impedance denoted by the symbol Z0, at which port means J, jth port. So square root of Z0 J. So to calculate now, for a better understanding, shall we see the scattering parameter of 4-port network. When you see the diagram, it is a 4-port network. There are 4 ports: port 1, port 2, and port 3, port 4. In that, A1 is the incident at the port 1. Likewise, B1 is the reflected wave at the port 1. So the similarly for all the other port cases, we have denoted the symbol as A and B at particular which port. So A is nothing but it indicates the incident wave and B indicates the reflected wave. So already we know Sij is the notation of scattering parameter. The formula is that normalized voltage wave reflected at the ith port divided by normalized voltage wave incident at the jth port. So before calculating the scattering matrix for 4-port network, we have to derive the scattering parameters. So there are 4 ports. So S11. So S11, it indicates Ij. Already I say Sij means I is indicates the incident wave and J, it indicates the reflected wave. So S in the previous slide, Sij is nothing but the normalized reflected wave at the ith port divided by normalized incident wave at the jth port. So from that, we are calculating the scattering parameters at port 1. So S11 is equal to B1 by A1, S12 is equal to B1 by A2. B is the reflected and 2 is the incident wave, and S13 B1 by A3, SN14 B1 by A4. So these are the scattering parameters at port 1. From this we have to calculate the reflected wave at the port 1. So reflected wave is nothing but the B1. You can see on all this S1 and S12, S13, S14, B1 is the common one. So total reflected wave at port 1 B1 can be calculated by, from this first one, B1 is nothing but S11 into A1. Like this, in second one S12 into A2, third one S13 into A3, and fourth one S14 into A4. So this equation represents the total reflected wave at port 1. Likewise, similarly we have to calculate the scattering parameters, and from that we have to calculate the total reflected wave at particular at each port. Now first we have calculated for port 1. Likewise, it is a 4 port network, we have to calculate for port 2, 3 and as well as 4. The same thing. So scattering parameters at port 2 means S21, S22, S23 and S24. Likewise, from that we will calculate the reflected wave at port 2. Reflected is denoted by symbol B. So at the port 2, so we have denoted as B2. And similarly, from the previous how we did, we will calculate the same for the port 3 and 4, the same calculation for reflected wave. So from these parameters, what we have calculated, the scattering parameters, port 1, 2, 3, 4, by using that we can form the scattering matrix for 4 port network. So B1, B2, B3, B4 and A1, A2, A3, A4 are the reflected and the incident wave. These S11, S12, S13, these are the scattering matrix, that is, these are the coefficients. When you see this in this matrix, the diagonal values S11, S22, S33, S44, this value gives us the this is nothing but these are the reflection, these are the coefficients. These coefficients we denote it as scattering matrix. From the by calculating the values from the diagonal, we can know about the return loss. From the value of the diagonal, we are able to calculate the return loss of the network. So scattering parameter is nothing but it is used for the analysis of microwave components. The main formula you should know, the notation is the Sij. So it is calculated by normalized reflected wave at the ith port divided by normalized incident wave at the jth port. We have seen the derivation of scattering matrix for the 4 port networks. So before calculating the scattering matrix, we have to derive the scattering parameters at each port, and from that scattering parameters we have to derive the total reflected wave at that particular port. From that we can derive the scattering matrix of the 4 port network. So from the diagonal value we are able to know the return loss of the network.